Let's talk a little bit about complements. Complement is an opposite or the inverse of a number. How it is going to be applied to the Boolean algebra? A is the variable, right? Variable could be 0 or 1. In digital logic we have two states, 0 or 1. So if I want to find the complement of A, I simply say this is A naught. It means if A equals 1, A naught is going to be equal 0. So if I want to find the complement for C, this is nothing else, just C naught. If I want to find complement of AB, AND gate, this is nothing else, just A, B naught. This is the NAND gate. If I want to find the complement of OR, this is nothing else, just A or B naught. If I want to find the complement of OR with inverter, what I have to do, this is nothing else, just C naught or D naught. We can apply over here the De Morgan's theorem, right? De Morgan's theorem says that you can cut this bar, but you have to change the sign. Make it a long story short, simply I'm going to have C naught naught and D naught, where naught and naught will cancel out, and my answer is going to be equal C D naught. So that's why this is very important to remember that C naught or D is the complement to C and D naught. Let's take a look at another example. If I want to find the complement of E and F naught, I simply write E F naught with bar, right? So I'm going to have again De Morgan's theorem, which is going to give me E naught or F naught naught. These two naughts are going to cancel out, and my answer is going to be E naught or F. Also, this is very important, especially when you are going to do simplification of the Boolean expression, to see that E, F naught is the complement to E or F. Remember that these variables can be replaced by different ones. Let's say this could be A, or it could be C, or X, or Y. If you want to find the complement of the exclusive OR, you simply just write A exclusive or B naught. If you want to find the complement of exclusive NOR, simply write A B naught naught. When the bars are equal in length, you're supposed to cancel them out. So the answer for this is going to be equal A exclusive or B. Simply, the inverse of the exclusive NOR gate is exclusive OR.